Okay, so we're going to go ahead and cover reference angles today. They are linked very directly to graphing a rotated angle or circular motion, as well as with coterminal angles that we talked about last time. It's just a real quick overview. Over here, we learned about the parts of an angle in standard position. We discussed how to graph an angle and how to find the degrees and the radians for the size of the angle based on our size of rotation, which is 360 per rotation or 2 pi. Over here for coterminals, our main focus was finding coterminal angles, which are angles that have the same terminal side to the end of the same place, but they have a different amount of rotation. And these are always going to be separated by a rotation or 2 rotations or 3 rotations or a multiple of 360 degrees or 2 pi. If you look here, this is a really good example. We have it in both colors. So it says to find a coterminal angle of negative 500 degrees. Remember, we graph the angle and then we find the coterminal angle based on subtracting or adding rotations. For this one, it was adding because it was a negative angle. Here is an example of us subtracting rotations. We were all the way up at 943. We wanted a coterminal that was between 0 and 360, so it'd be on the unit circle. So we subtracted rotations until we found that the coterm was 223. Okay, today we're going to talk about reference angles. Reference angles are always going to be positive and they're always going to be acute, which means less than 90 degrees. So reference angles are positive, acute, I'm going to put in parentheses, less than 90 degrees, angles formed between an angle's terminal side and the x-axis. Here it says, give an example. I'm going to do 2. So let's do one that's just going to be like a normal, actually, let's do a negative one. If we did like negative 250 degrees. So we'll draw our angle in standard position. Here is our vertex, our initial side. And if we're going in the negative direction, we're going down. And I'm going to go negative 250. As we know, this is 90. That would be 180. This is 360. And this one would be 270 because 90 times 3, 9 times 3 is 27 at the 0. So I'm going negative 250. This is negative 180. And then the difference from 180 to 250 would be 70 more. So I'm going to go 70 more, probably like right here. Put my little arrow and draw my terminal side. So here is a graph of the angle negative 250 degrees. And we want to find its reference angle, which is the distance from its terminal side back to the x-axis. We'll label that reference. Now, the way we could do that, let's see. We know this much is 250. We know half of a circle is 180. So we could just find the difference, right? If we know this is 250 and we took away 180, we'd be left with this chunk right here, which is our reference angle. So the difference from 250 to 180 is 70 degrees. So I'm going to label that. The reference here is 70 degrees. Okay, let's look at the next one that we're going to write right here. For this one, I want to show you an example of if you have more than one rotation, so over 360 degrees. So let's do 735. So I'm going to draw my angle in standard form, or position, sorry. Here's my vertex and my initial side. 735 is bigger than 360, so it definitely goes around once, and it's positive, so we're going to go in the positive direction. And then it's 735 is still bigger than 720. 720 is 2 rotations, so I'm going to go around another time. There we go. And then that was 720, so I have 15 more because 720 is 15 short of our 735. I'm going to go just a little bit over, probably like there, and then draw my terminal side. Now this is in quadrant 1. The way you're going to work it if you have an angle that is not on the unit circle, so it's too big, has multiple rotations, is you're just going to still same thing we did do. Look at the difference of the terminal side compared to the x-axis. So it's this little chunk right here. Remember when we were doing it, we said we had 2 rotations and then this extra little chunk here, that was this extra 15 degrees. I knew that because 1 rotation is 360 and 2 rotations, so 360 plus 360, is 720, and I need 15 more to be up to 735. So this difference here was our 15 degrees, and that is still also the distance between our terminal side and the x-axis. And it'll be a little bit easier once we look at the next section. I'm going to talk about our little tricks that we can do per quadrant. Okay, looking down here, we have quadrants versus reference angles. I'm going to have us label our quadrants. So this is 0 degrees to 90. Quadrant 2 starts at 90 and goes to 180. Quadrant 3 starts at 180 and goes to 270. And quadrant 4 starts at 270 and goes to 360. Okay. This part here says, if in quadrant 1, the angle is blank to its reference angle. So if we had an angle whose terminal side ends here in quadrant 1, this is our reference right there, that distance. It's going to actually be equivalent to our reference angle because that is the distance it is from the x-axis. Looking at quadrant 2, if in quadrant 2, the reference is blank, the angle and the negative x-axis. So if I have my vertex and I cross through this as my terminal side, this is the distance from my terminal side to the x-axis, specifically the negative side of the x-axis. You'll notice that that reference angle is between your terminal side and the x-axis. Looking at quadrant 3, so I'm going to draw my vertex and just a random terminal side. If you look at this one is actually below our x-axis. So it's going to come up and meet right there. So our reference there is in between, still in between again, our terminal side and our negative x-axis. Specifically, it's going to be below the space below the axis and above the terminal side. So here it says in quadrant 3, the reference is above the angle, and by that I specifically mean the terminal side of the angle. Sorry, I should have specified that when typing this. And below the negative x-axis. And then lastly, quadrant 4. So if you were to end in quadrant 4, the reference angle is this space right here, which is, you'll notice, above our angle and below the x-axis. So this one we're still just going to say between, right? It's between the angle, specifically the terminal side, and the positive x-axis. Good. Our next part here is going to help with our finding of our reference angles by quadrant. What I want you to do first, though, is draw a little line here, a little less than halfway. And right here, we're just going to specify when you're finding your reference angles, you're always going to need to start with the terminal side of your angle, right, wherever it ends. And when you're working with a terminal side, if your angle is less than or greater than 0 to 360 or 0 to 2 pi, you will need to use the coterminal angle that's between 0 and 360 or 0 and 2 pi when calculating for your reference angle. So here you're going to say must be an angle or a coterm between 0 and 360 degrees or 0 and 2 pi. It will not work if you were to do, like, let's say you ended in quadrant 1 and you said, okay, well, my angle is 390 degrees because that would end in quadrant 1. That doesn't make sense, right? Because our reference angle has to be between 0 and 90 because it's an acute angle. Okay, let's do quadrant 1 here, right? We said it's going to be equivalent. So quadrant 1, your reference angle is equal to your original angle or your original coterminal angle. That's between 0 and 360. Quadrant 2, so if you end in quadrant 2, right, if this is my angle, and I know this is 180, my reference is this difference right here. So what you're going to do is just take 180 and subtract your angle, and that'll give you what's left over. So here our reference is 180 minus our angle or our coterminal. Okay, quadrant 3, here it is here. So for quadrant 3, if this is my angle, I couldn't just do the same thing as last time, right? But it's going to be similar. So this is my angle. I know this is 180. If I were to do my angle and then subtract this 180, that would give me this little chunk or slice left here, and that would give me the reference angle. So reference equals the angle minus 180. And then lastly, our quadrant 4. This one, our angle is here, right? And if I were to go all the way around, that is 360 degrees. So if I did all the way around and I subtracted my angle, that would leave me left with this part right here, which is our reference angle. Oops, sorry, I forgot to write reference. Here we go. Reference equals 360 minus the angle or the coterminal. Good. So this is a great, right here's a really good resource, this portion of the paper. Down here we have 3 examples. So we'll start here with reference angle 70 degrees. I'm starting with an angle of 70 degrees. If you look at your quadrants, that is in quadrant 1 because it's between 0 and 90. This is in quadrant 1. I'm going to go ahead and draw it. So I put my vertex, my initial side. I know straight up and down here is 90. I know halfway is 45. I know 2/3 of the way is 60. So it's going to be a little bigger than 60. So I'm going to go like right there. And here's my rotation. If I want to do my reference angle, it is going to be this space here. It is in quadrant 1. So because we're in quadrant 1, our reference angle is equal to our angle, which is 70 degrees. Okay, I would encourage you to pause the video, try these 2, and then come back when you're ready. Okay, we're going to go over what you have for the first one. We have reference angle of 280 degrees. So I'm going to look first and see where 280 is. 280 is here in quadrant 4. So I'm going to mark quadrant 4. Now that's where I'm supposed to end. So I'm going to go ahead and draw my angle. Here's my vertex, my initial side. I know that this is 270. I need 280. So I'm going to go 10 more. It's going to be a real small little chunk. And then that would be there. That might have been a little bit too big, but close enough. Now, this is my reference right here. Remember, it's the space between your terminal side and the x-axis. And I know that if I went all the way around, this would be 360. So if I take away how far I did go, that would leave me left with this part right here. So take away my 280. And I just type this into the calculator, and I would be left with 80 degrees. So that is my reference. And this last one that you finished, this one was 140 degrees, which is in, let's look up here, quadrant 2, just about halfway in quadrant 2. So this is in quadrant 2. So I know it's going to end over here somewhere. I'm going to draw it. So here's my initial side. I know this is 90. I know that halfway between 90 and 180 is 45 degrees because half of 90 is 45. So I'm going to go a little bit more than halfway because I need to go 50. So right there should be good enough. There we go. Here's our angle. So that means this here, this space is our reference angle. And we're in quadrant 2. So I know that if I were to do here, this is 180. And if I took away my angle, I'd be left with this space here. So 180 minus my angle, and that gives me a total reference angle of 40 degrees. And there you go. So the key here, especially if you have an angle that is bigger or smaller than your unit circle, so a negative or a big positive, What you're going to have to do first is find your coterminal angle between 0 and 360. And from there, use that coterminal angle, because it'll be the right termination point, to find your quadrant, and then from there to find your reference angle. So let's go back. I know we've already written this one. I just want to show you again using our tools we just had with this one. So if I know I'm at 735, I want to find my coterminal angle. So I'm going to subtract rotations until I get there. And remember, that would give me 15 degrees. And then what I would do is look, that's my coterminal angle. I'm going to label that. That's my coterm between 0 and 360. Then I'm going to use that coterm. I'm going to look here. And I'm going to say, okay, well, 15 degrees ends in quadrant 1. And per our directions, our reference angle is equal to our coterminal if it's in quadrant 1. So this is also the reference angle. Let's do it with this one as well. So I'm going to erase, just show you how we could get there. So for this one, we're at -250. I need to find my coterminal angle that's on the unit circle between 0 and 360. So what I would do there is just add rotations till I get to a positive number. And that should put me at a positive number. Let's go ahead and type that into my calculator. -250 plus 360. That gets me to 110 degrees. So this is my coterm. And now I will look, see which quadrant that's in. And that's right here between 90 and 180. So according to my paper, remember to do that one, what we're going to do is we know this is 180. We know we went this far because that's our 110 if we were just doing the coterminal angle. So I subtract 180 minus my 110, and that gives me my reference angle of 70 degrees. And there we go. Hope this helps. Bye.